My name's Brandon Gogetap, and today we'll be talking about reactive programming with RxJava and specifically how that relates to Android. I'm going to be going through pretty quick. RxJava is a very broad topic and it has a relatively steep learning curve, so I'm not going to cover all the basics because there are a lot of good talks out there that will do that for you. I mostly just want to show kind of the cool things that are possible with using it. So reactive programming is basically dealing with asynchronous streams of data and events. Almost anything can be a stream. It could be a single value UI events like touches on a view or individual items from a list or other collection. So some examples are user clicks on a view and we react by performing some logic on a click listener. Data loaded from HTTP request, we react by parsing that data and displaying it in a view somehow. Or an exception's thrown while doing some exception-prone work, and we react by displaying an error message, logging that error, recovering if we can, etc. So basically callbacks, but there's much more, and it's much more powerful than just callbacks. So callbacks are the main way we handle asynchronous events, and they can add up fast. So some of the downsides of getting into, as they call callback hell, is logic can be split up across classes, or even if it's in the same class, it can be just kind of all over, not following any sort of logical stream. The ordering of the events can be hard to follow or visualize in your head. And handling multiple threads can be difficult or at best verbose. And that goes the same with error handling. If you have to handle or check for errors in every separate callback, you could be doing a lot of repetition. So one example of a callback is this is a retrofit service interface, and to kind of do the built-in way of starting a request, we would call .enqueue on the service and pass in a new callback, which has two methods, on response and on failure. And here it's nice because threading is basically handled for us. We don't really have to worry about it in this case. But if we have another service that we have to call that depends on this first service, we either have to assign a variable, so we have state in our class now. So here we're assigning friend ID to some part of the response that we got in our first request, and we're using that to make our second request, which is getting the details of a friend. And again, we have the same two callbacks, on response and on failure, that we have to handle individually. So this is kind of the least amount of code that you could have to deal with two requests that need to be executed synchronously, because one depends on the other. So using callbacks, a lot of the time you deal with state, and that can lead to side effects, which and kind of the functional programming definition side effects are essentially state. So they're not inherently bad, especially in imperative programming languages, because that's kind of how a lot of stuff has to be done. But they can be unpredictable. It can lead to hard to debug scenarios. And following the logic isn't as clear as we'd like. So how can we do better? Extreme basics of functional programming, and anybody who actually has experience in functional programming, don't hate me. But it's essentially programming without assignments or state. You have values that are computed and shared with subsequent functions, and this continues until you get your final result. So you have one input and you will always get the same output given that same input. There's no state, it's very predictable, and logic is easy to follow. So functional reactive programming kind of combines those two concepts, and that's kind of what is used to describe RxJava. It gives predictable results without worrying about side effects, or at least minimizing the amount of state that we have in our classes. And logic for one stream is concentrated in one place, and the functions that compose that stream could be split across different classes, but the actual stream reads like a sentence and it's in one spot and it's easy to follow. So back to our callback, this is what our two requests callback framework looks like. And if we were to use a functional reactive programming setup, we could get it down to something like this. And so here we're doing the same things. We are starting off with our first request, which is an observable now, and Retrofit has a very easy integration with RxJava to turn your interface methods into observables. We flat map it, which basically gives us the result of that first request and allows us to return another observable. So here we're doing the same thing we did before. We are using the friend ID from the first request and passing that into the second request. And then with these two operators, we define our threading. So we want to start on an IO thread, and when we subscribe, we want to be on the main thread because we're probably dealing with views. Obviously, that can be left off as needed. And then finally, the subscribe block, which kicks off the whole chain, ends with friend details. So that's the result of our second response, since that was the last piece of our chain. That's what we're going to deal with in the subscribe callback. And we also have one place to handle errors here. So that makes it simpler. And we'll talk about the different operators and the syntax more as we go on. So this is basically all the logic of the previous callback screen that we saw. And there are no assignments there. Everything is just computed by combining functions together. The logic is easy to follow, and error handling simplified. And this is obviously a very basic example, but imagine if you wanted to add another request to that chain. At that point, you could probably talk to whatever service you're using to fix needing to call 3 synchronous requests, but this is for example. So you could be saying that I can do the callback way without assignments too. And yeah, that's true, but you either end up with nested callbacks like this, or again, no kind of clear path of your stream of logic. And then if we added a third one, it can just go on and on. And we have 3 on failure cases we have to handle here separately. It just becomes a mess. So nothing that RxJava gives you, or I should say RxJava doesn't give you anything that you can't do without it. But it makes it cleaner. It makes it hopefully easier to debug and kind of read as somebody reading through the code. And this is an example if we had to add that third request to our observable stream. We could add a do on next, which gives us access to that friend details response before we pass that down the stream, so we could do something with that. And then we could flat map it again to our third request. And now our subscribe block is dealing with the result of the third request, since that was the last function in our chain. Yeah.
When you have chain calls like that, let's say first call failed, how do you observe that?
So that will be bubbled up to your on error, or where the throwable is here in your subscribe method. So at any point in the chain an error happens, you will catch it there. So that is usually fine. Sometimes you have to handle errors at different points in different ways, and there are operators do on error that you can insert at any point here to intercept an error at that point. So now to more RxJava specifically. Reactive Extensions is actually a framework that was developed by Microsoft, and it was ported to many other most popular languages. And RxJava is specifically the one we'll be talking about. But the nice thing is, if you get used to the syntax and the flow, the operators of one Reactive Extensions based port, you can use it in other languages relatively easily. RxJava specifically was ported by Netflix. Version 1 is stable now. It's very robust. It's been through many iterations and is going to be supported for several years. Version 2 is actually in developer preview. There are quite a few changes. It's not like a drop-in replacement, so if you were to start using it right now, I would definitely stick with version 1. RxJava benefits are easy threading. There's a large amount of operators, so you can transform or work with your stream of data, and there are operators for most anything you'd like to do. And simplified error handling, like I said before. Some downsides are it has a very steep learning curve, mostly because of the amount of operators. You could be kind of going way out of your way to do something when there's an operator that is exactly what you want. But there are so many that it definitely takes a long time to pick up. And going beyond the basic like async task replacement kind of requires a new mindset. Reactive programming is a different way of programming than like traditional imperatives, so it could be hard to figure out when you want to use it and maybe not using it where you don't necessarily need to. And I'm definitely not completely there yet. The other good thing, though, is that it's very easy to drop in piece by piece. You can use it in one method, one piece of your app with no requirement to kind of have your entire code base be reactive or observable based. So there are two main building blocks of RxJava, or Reactive Extensions actually as a whole, and that's observables and observers. Operators are what you apply on observables, so I listed them as kind of a big point because they are probably the most used piece. Observables are objects that can be subscribed to, and they emit the items. So the results of that request from retrofit is from an observable. You're subscribing to an observable, and when it has a result to give to you, it emits that. And so they're the building block of your whole stream. And observers just subscribe to observables, and it just has three methods: on next, on complete, and on error. On next is called every time the observable wants to emit an item. So if an observable has a subscriber or an observer, a subscriber is a subclass of or implements observers. So I may be using those interchangeably. If the observable has a subscriber and it wants to emit an item, it will call on next on that subscriber with the item as the argument. And on complete is what an observable will call when it will no longer be emitting any items. And so this is known as a terminal event. After that, that observable is done. And on error is another terminal event, and that's called anytime a exception is thrown during an observable, while an observable is subscribed to. And again, once that's thrown, that observable is done and will not be calling on next or any other operators. So the simplest case for RxJava is just emitting one item, and they have a static creation method for that called just. So here we are just emitting a string with the value hello, and to subscribe to that, we pass in a subscriber, which again takes or has three methods. So if you don't have a subscriber to pass in, you implement those three methods. And the first one is an action one, which is just a callback that has, it provides one argument and doesn't expect anything in return. And so here we would be logging hello, and that's the on next call. The next would be on error, and that's also an action one that provides a throwable and again doesn't expect anything in return. And then on complete is an action 0. It's just an empty callback that's saying we're done. There's no data for you to use in there. So this is extremely verbose, and I would go as far as to say if you're not going to use retro lambda or Jack compiler, that RxJava isn't worth it. Obviously you're not getting anything besides easier to read code with those two frameworks, but if you use RxJava heavily, it's not going to be easy to follow, which is kind of one of the benefits that I give to it, but that's because of lambdas. So we can take this exact same stream and convert it to this with Retro Lambda or Jack Compiler. And most of the time you don't even care about on complete, so you don't need to pass in anything for that. And if you're really feeling wild, you don't even have to pass anything in for the error, so you can just subscribe and pass in a callback or a function to deal with on next. The one thing I would say, or argument I would say against doing this, is if an error is thrown, your stack trace will show an on error not implemented exception, and it will likely not have any reference to your own code. So unless you have one observable in your code base and you throw an error after you add it and know exactly where to go, you could be in trouble if you don't. So I would always suggest at least providing something to handle on next and something to handle the error state. So observables, like I said, are the building block of the observable chain operators for most anything you want to do with it, filtering, mapping, things like that. And they're in charge of calling on next, on complete, and on error on their subscribers. They're also in charge of handling back pressure. So that's a state you can get in if your observable is emitting items faster than the subscriber can process them. And it's also one of the reasons that you unfortunately shouldn't use the observable.create method, which is where you can create your own observable. And it's unfortunately named that, but if you create your own observable, you are in charge of handling back pressure, and most experts on RxJava recommend not to use it, so I believe them. There are a lot of static creation methods that you can use to get around that, and we'll go through a few of them in a sec. The other building block or potential building block in RxJava are subjects, and these are observables and observers. So they can emit items and they can also be subscribed. So here we'll show an example of when you would use them. They're good for bridging non-reactive APIs, like maybe broadcast receivers. So we can look at it here. If you have, let's say, a broadcast receiver that listens for network changes, and you want to know if the current active network is Wi-Fi. So we assign that to a Boolean, and we call on our subjects, we call on next with that Boolean. In a service that won't upload unless we are on Wi-Fi, let's say, we can subscribe to that same subject and receive that on next call in the subscribe block. So they kind of act as both, and this is how you can use them as an event bus. And I say more explicitly because the nice thing about doing it this way is you can chain operators at this point if you didn't want to call on subscribe, if you only wanted to get that subscribe. If the is Wi-Fi was true, let's say, you could throw a filter on there and not ever have to worry about dealing with the false state. That's just one example. Probably wouldn't be the best in this specific case, but now the operators, which are the more tricky part of RxJava. So they can transform a stream, they can give you access to the emitted items at any point in the stream, and you use them to specify schedulers to run on. And so here is an example of and we saw this earlier, but probably the two most common operators you'd use in Android are subscribe on and observe on. And what subscribe on does is says when you subscribe, from the very beginning, this is what you want your observable chain. This is the thread you want your observable chain to start on. So the thing to remember with that is only the first one counts. So if you were exposing an observable from a database, let's say, and you want to force everybody to subscribe to that observable on a database thread from a scheduler that you have for the database, if you call subscribe on there, if somebody that wanted to use it said, I want to subscribe on the main thread because for whatever reason, that wouldn't work. All it would do is introduce just that tiny bit of overhead of thread hopping, but the actual operations would be done on the database thread or wherever subscribe on was called first. So that can be called once. Observe on can be called as many times as needed, and everything downstream, so in this case subscribe, everything downstream from observe on will run on the thread specified there. Map is another big operator. What that does is take an emitted item and you can transform it in some way. So if you have an observable that's emitting integers, you can have a map function that multiplies those integers by 10, and now everything downstream from that map function will see the integer multiplied by 10. Flat map is another one that's similar but very different in a way. It gets the same input, so it gets that emitted item the same that map does, but it can create an observable from it. So I'm going to actually just wait till we start looking at the diagrams because it's a little hard to explain. Zip and zip with are ways that you can combine observables. So if you don't want to do anything until 2 separate asynchronous tasks complete, you can zip them as observables, and the callback you get in there will only be called once both of those observables call on next. So that can definitely be handy. And combine latest is similar to zip, except it doesn't need both of them to call on next. Each time one of your observables that are combined calls on next, it will call into the function you provided with the latest values from both observables. And this is, filter is a pretty simple one. If you have an observable emitting integers and you only want to deal with even numbers, you can have a filter with a predicate that says the integer divided by 2. And do on next is the other one we looked at earlier, and that just gives you access to the emitted item at some point in the stream. So in our request example, we were making 3 separate requests, but in the subscribe block, we only got the response from the 3rd request. If you needed to do something else with the 1st or 2nd, you can put a do on next somewhere in the stream there, deal with it, and then let the stream proceed. And if you start using RxJava, you will probably be seeing a lot of these. They're called marble diagrams, and once you take the time to kind of understand why they're built like they are, they do tend to make sense. So in map's case, the straight lines or the arrows are observable streams, and then in the middle is your operator. So here we have a stream of 1, 2, 3, and each of those items is passed through the map operator, which is multiplying it by 10. So everything downstream from it sees 10, 20, 30. And then flat map, in this example, you have an observable emitting, let's say, colored circles, and you're flat mapping them to an observable that emits colored diamonds. So with one input, our downstream is seeing 2 outputs from one input. So that's how it's different from flat map or from map. With map, you get 1 input, you give 1 output. With flat map, you can give an observable which emits multiple outputs. And it's called flat map because you are essentially making separate observable streams, but you're flattening them into one stream. And so that kind of explains the picture here. And at this point, I think I want to look at some of the other marble diagrams available. Yeah.
You go back to that marble diagrams.
Yeah, we'll look at a lot more here.
Okay.
So this is the map one. It's not very cool because moving them doesn't really do anything. But if we look at something like zip. So here you have 2 observables that you're zipping, and this is only called after each one calls on next. So this can get you in trouble with back pressure. So if we move this one, let's get that out of the way more. So we've emitted 1 and 2 up here before we've emitted A, but since we haven't emitted a second one from this, our downstream observable is not getting another emitted item yet. So if we move this over here, we're getting to B. So that's there. If we put C here in, then that one will turn to 2C. So zip is good if you have two observables that are going to emit the same amount of items. If you have one that's faster than the other, you will probably throw an on back pressure exception at some point. The buffer is not very large. I tested it with just clicking a button, and I think after I got to 15, I threw the error. So that's definitely not something you want to use with uneven emitting observables. Combine latest, however, does same thing. It deals with two observables, but after each one emits, it will, so it does wait for the first. It waits, they each have to emit once, but after that, it will just emit the previous value. So our bottom observable here has emitted A, B. Well, the top has only emitted 1. So when B is emitted, we get 1B in our combined function, essentially. So this, I don't think you could get in trouble with back pressure unless one of your observables never emits. But it also may not be what you need because it could be emitting stale data. So there's use cases for all of these. And these are not, this isn't an exhaustive list. It doesn't even have flat maps. So if you want to see the full list, if you go to the Reactive X documentation, there's operators or lists for all different things. And this one we already. Did you have a question about this one specifically, or just wanted to see it more? Or was it the map?
So, I guess my question was, is there any particular reason why the green and blue
Aren't in order?
are alternating?
Yes.
Like emphasizing the fact that things are asynchronous.
Yes. So in
But it
flat
doesn't
maps,
necessarily have to be that way.
it likely will never be that way, but they have it like this to show you that flat map specifically does not guarantee order.
Okay.
So if you have one observable that has slowed down for whatever reason, so yeah, your green observable emitted its second item after your blue had already started emitting, you will get them as they come with flat map. There is, if you do need order guaranteed, this concat map does guarantee order. It's the exact same as flat map, but if you have an observable from your second emitted item or created from your second emitted item from your source chain, all its emitted items will come before the observable created from your third emitted item from source chain. So they're exactly the same except for ordering. But again, in practice, I haven't personally even used concat map, but in practice, flat map will probably behave how you'd expect, but it's not guaranteed. So yeah, that's why they had them. They do explicitly put it like that so you can understand. Okay, so if you're like me, listening to somebody talk about it or even reading probably doesn't do a whole lot until you start using it. So the best place to start, in my opinion, is async task replacements. Retrofit requests are another easy one. Like I said, you just have to provide a call adapter factory, which Square provides as another Gradle dependency to your retrofit instance, and in your interfaces, just calling or having it return an observable instead of a call of whatever response will be all that you need, and you can use it as an observable. List filtering, so since we don't have like streams or the mapping function of Java 8 in Java 7 or Java 6, 7, whatever we're stuck with in Android, list filtering is something you can use. I put an asterisk because there is an overhead with creating observables and wrapping all these things in observables and applying operators on them. So I did a test with using, actually I'm going to wait because I have an example of it. I'll tell you the results of that test later. Yeah.
Do you always use observables with retrofit, or so if it's only if the case, if the situation?
Right now, it's situational. There's one very specific case where it came in handy, and I'll show you what that allowed us to do later. I probably will be working on our base requester classes to make them all take observables, but that's just to kind of make things more uniform. Yeah, there's nothing inherently wrong, especially if you're just dealing with the response and passing it to something. I'd say if you're not going to be applying operators to things, or if applying operators to things won't make your situation better, then it's probably not necessary, but it's also not a bad thing, I would say. So here is an example of a very simple async task. And on the left we have our class, and just to be fair to async task, we're going to ignore all lifecycle events. We have this as a separate class. It doesn't carry an implicit reference to our main activity or anything like that. So this is the best case scenario for an async task. So we still have to create a class. We have to probably create an interface because we're not inside an enclosing class which we can call methods on. So we have an interface to call the results to. Then we have to instantiate it and then call execute on it with whatever our input happens to be. And with RxJava, we can take that long-running function method and just wrap it in an observable. And that's what fromCallable does. You can pass in any existing method you have to this fromCallable static creation, and it'll basically just wrap that in an observable. We specify our threading, and then we subscribe. So these are kind of the equivalents in each case. So the do and background, callback, and async task is similar to just our creation method here. Oh, I guess that's all I showed. And I thought I highlighted the rest of the similarities, but apparently not. So new async task example, slightly more complicated. We want to filter a list of messages and return a new list that has all messages that contain that search term. So a little bit more setup here. We have the same class, same instantiation, but we have to provide a list when we instantiate the async task and assign that to a field inside the async task class. And we go through a for loop, and if it contains our search term, we add it to our new filtered list and then return that. And then in on-post execute, we call our listener or give the filtered list to our listener. And with RxJava, we just have to add one operator, the filter, well, two operators, but the filter, which we pass in a predicate, which is just a Boolean. So we get each item at that point, and we say if it contains the search term, then let it proceed. And then the toList operator basically holds on to all omitted items up to that point. And once the upstream observable calls on complete and says I'm done omitting items, it puts it in a list. And so when you subscribe, you get that list of items. And here must be where I highlighted all these similarities. So for loop on the async task is replaced by these few lines in RxJava. And then we have our threading, which, to be fair, async task handles for us. And then the on-post execute is just what we would do in subscribe. And since we can do this inside of our class that's calling it, so the same class that would be instantiating the async task, let's say, we don't need an interface. We can just call this display messages that would have been an interface method. But in this case, that display messages takes in a list of messages, and since a list of messages is what we are getting in that subscribe, we can use this method reference syntax, which is nice and concise. And so retrofit callbacks versus observables. Again, we kind of went over this in the beginning, but mainly you just get kind of easier error handling. But on the whole, callbacks themselves for retrofit aren't, I don't think, vital to replace. So calling in queue is the same as calling our observable and giving it the threads we want to run on. And on response, the same. We just can call a method reference theoretically. And same with the on failure. It's just another method reference if we have a method that handles that error. Or we could do it in line as well. And I put these down here. This is hard to read, but I'll put these slides up. Basically what you'd need if you wanted to add that call adapter factory to your retrofit instance. You have to add another dependency with the retrofit version, and then where you are creating your retrofit instance, just add call adapter factory and pass in that RxJava call adapter factory. And what retrofit does is for any return value that it sees in your interface, it will go through all of its call adapter factories, and once it finds one that can conform or can handle that return value, it uses it. So this is all the setup that's needed. And the list filtering, and this is what I told you, I did a little experiment. I used a list of 10,000 integers, and I applied this same predicate to it, basically integer modulo 3 equals 0, and I added that to my filtered list. And in the for loop, it ran in 5 milliseconds, I believe, and the observable took 13. So there's definitely overhead, but this was a list of 10,000 items, and still taking 13 milliseconds is not huge. So if it makes sense, I'm not saying go replace all your for loops with observables, but if it makes sense, if you need to do maybe any other sort of transformation on that stream, I would definitely not avoid using observables because of the overhead that they give. And this is just an example from the Builder Trend app. We had to support uploading to Vimeo, and this is where I first started using observables for retrofit. Basically, we have to make, I think, 5 different service calls throughout the upload process, and these 2, so from scratch, this is the entire stream, from a user saying upload this video to our upload being saved in Builder Trend. And obviously these functions all have their own logic, but to just have it kind of written out like a sentence like that makes it really easy to follow, and you can deal with the individual logic of, let's say, getting the upload status from Vimeo in its own isolated area. And then the resume is just if upload, or if the app got killed and there's a resumable upload, it has a slightly different path, but essentially that's all the logic to uploading the video, and it encompasses, like I said, I think 5 separate service requests, a few to Vimeo and a few to Builder Trend. So it's really powerful, and once you kind of get the hang of it, I think it makes code easier to read. Quite a few links here that I would recommend following. Dan Liu has given talks and written blog posts on RxJava for a couple years now, and he's very, very good at explaining concepts. So I'd recommend reading anything by him or listening to his talks. Some more advanced stuff by Jake and Dan is out there as well, so once you start to get a little more comfortable and just kind of want to learn how it's working under the hood, those are good talks to read. And then the libraries themselves, to get started on Android, you just need RxJava and RxAndroid. Well, really RxJava, but if you want to do any sort of threading, you should probably get RxAndroid as well. And then RxRelay is a library by Jake that is made to replace subjects. So the problem with subjects, if you are, let's say, using a subject that's going to be used across your application lifecycle, if it receives a terminal event like on complete or on error, then it's done. You won't get any more omitted items from that, so that make for a pretty crappy event bus. So RxRelay is essentially just subjects that are impossible to call terminal events on. So they will never have an on complete or on error state, so you can always count on them to be emitting items when they should. Then RxBinding is another library I brought up earlier that gives you hooks into views like on click, on text change, things like that, and converts and just gives you observables rather than having to provide a click listener callback. And that is it. Any questions?
You looked into Java streams at all on your list filtering? I don't know if you looked at it, but
I haven't checked performance actually. So yeah, I knew it was capable, but I guess I haven't even used Java 8. So that would be very interesting to try actually. Yeah, I would think that it would be more performant because if you start looking through the RxJava and the observable chains, there's a lot going on in the background, and I mean there's got to be overhead. So I would assume that Java 8 streams would be more performant. Yeah.
This is more on like what is this just PowerPoint?
Keynote.
Keynote, so you have to manually highlight.
If you copy from Android Studio, it copies in rich text. So when you paste, you retain all the colors. And I just made my background color match the background color of my IDE, so everything just looks like it's.
So then, like, to grade out the lines that you want to focus on.
Oh yeah, to change, yeah. I set up a color palette to make that slightly easier, but there's still some manual work in there to kind of de-emphasize code and stuff.
So I have one question. So if you are changing like 3 calls, is it possible to use the result of the first one to actually call for the third one?
For the third one, if you zipped the first and second one, yes. So that's one thing that I've still am kind of figuring out. If you want to use something at the very top or upstream of your observable chain way downstream, I haven't figured out a good, or if that's even, I don't think it's necessarily possible. I mean, you could, if we're trying to avoid this, you could assign that to a field in whatever class you're in, but then you're kind of throwing away everything. So I don't think, I think that's kind of anti-pattern. Yeah, so if you need to use it immediately below with your previous 2, that's easy. You can do zip. And that will wait until both of those call on next, so you're guaranteed that both the 2 observables you zipped are finished by the time you get a function. And that function, I don't know if you saw, bad thing about retro lambda is it kind of hides a lot of the things, but basically these flat maps and map operators take in a func1, which just means it has 1 input and it expects something returned. And when you use zip, you have a func2, which has 2 inputs, which is the 2 emitted items from your zipped observables, and it expects 1 thing returned. So you can still proceed down your chain after that, but it just takes in a slightly different function. All right. Thank you, everybody.